Let me show you what I see. It's 2 a.m. and you're walking down an alley. There's trash everywhere. Chicken bones, wrappers, bottles of all kinds, tattered clothing and rags, feces, debris. People are combing through the trash and looking for usable items to bring back to the slab of cement that they're temporarily squatting on for the night. One man uses a snow shovel to clear a path through the trash to his tent. You stop and observe. As your eyes adjust, you appreciate rats, dozens of them, scurrying across the street, searching through the trash and darting around the people, including you, standing in the middle of their habitat, their home. These are brown or Norway rats, scientifically referred to as Rattus norvegicus. They're urban exploiters who thrive in the cracks of our forgotten buildings and the trash of our lives, who persist in our urban centers solely because our species, Homo sapiens, provide shelter and food to support their populations. In this context, could a disease jump from a rat to a human and then cause a pandemic? That is the million-dollar question, the needle in the haystack. How can we prevent the next global pandemic like the one we're experiencing now, an event of such magnitude that's actually quite rare compared to the transmission of bacteria and viruses that is constantly occurring between us, our environment, and other species, like the rats among us. Just like a virus that causes the common cold circulates in a room full of toddlers, bacteria and viruses are also circulating amongst the other species of animals that we share an urban habitat with. And some of these bacteria and viruses can jump from animals to humans and cause disease, called zoonoses. What risk does this pose to humans and the ecosystems we live in? Can we better understand when and why a bacteria or a virus from one species, like the rat, gets transmitted to another species, the human race? Can we detect and learn from these patterns to protect vulnerable populations? That is the focus of my research. Now, since I've been talking about rats and disease, your skin may already be crawling as you recount the infamous Black Death or plague caused by the bacteria Yersinia pestis, which was transmitted from rats to humans by fleas and which claimed the lives of over 75 million people. Clearly, our health is influenced by the rats that we share an urban habitat with. And we can learn about ways to improve public health by studying the rats among us. Less well known is another species of bacteria, Leptospira, which can infect humans and animals and cause a range of clinical symptoms ranging from asymptomatic infection to multi-system organ failure and death. These images depict the spiral-shaped bacteria or spirochete in a rat's kidney. We know from our research that pathogenic Leptospira are circulating right here in Boston. We've tested over 250 rats and found that about 20% of them are carrying the bacteria that causes leptospirosis in humans. And these images that you see here come from Boston rats. Time to freak out? Not really. Rats, along with other mammals, are considered a reservoir for leptospirosis, which means that the bacteria normally lives, grows, and multiplies in rats. But we, you and I, we have a floor under our feet. We have a roof over our Zoom screen. Despite the fact that rats live amongst us, and yes, they likely live around your home if you're living in an urban center, we do not have extensive contact with them. But what about highly vulnerable human populations living on the streets, which places them at elevated risk for contact with rodents? Areas where sanitation is poor, where buildings are unkempt, where pavement predominates and city residents avoid. Our group is working now to understand the risk of leptospirosis transmission from rats to humans living in an urban environment. We are studying the built and environmental parameters like poor sanitation, precipitation, and temperature that favor the growth and persistence of the bacteria. And we're studying the different species of Leptospira that are present in the rats in this area. This is important information required to develop effective vaccines against leptospirosis for us and our companion animals. Finally, we hope to extend our surveillance to vulnerable human populations to increase our understanding of the burden of this historically neglected disease in the United States, which anecdotally is increasing in humans and dogs, and which will likely increase as climate change drives warm weather, precipitation, and flooding, all parameters that contribute to the persistence of leptospirosis in urban environments. How are we doing this? We creep through alleys at night and trap rats. We set up field stations to collect our samples. We use tools, including remote sensing devices and geospatial analysis like the map you see on this slide, and whole genome sequencing to generate our data and understand our results. And most importantly, we spend time in the field observing our surroundings to better understand the context of the urban ecosystem we are studying and to answer some of the questions I have posed for you today. So maybe the next time you see a rat scurrying through the street, you'll ponder, what can be learned to improve our health by studying the rats among us? Thank you.